So the bind program started with this one question: can you grind these without using one line of code? So polishing these vein parts without any programming. So what is the current situation in material removal of surface finishing? So first of all, it is a very harsh environment where you see explosion risk or toxic fumes. There are still a lot of physical injuries like vibration, white fingers, or accidents with high-speed tools. And like you see here on the picture, it still required a lot of safety equipment. And last but not least, there is also a decrease in workforce because it is a very unattractive job to do. So why don't we use robots? First of all, there is not one solution that fits all. You have different abrasive, different tools, and different materials, and it makes it very difficult to automate. There are some specialized solutions, but they mostly require high volume. There's also some flexible solutions, but they're mostly not addressed to complex tasks. And when they add complexity, they also increases the amount of programming that's needed. So Nordbo Robotics is focused on bringing flexibility, but also be able to bring also still complexity to a certain task. So how do we solve this? So on one side you have the human worker, and he is so flexible because he uses his senses. We apply the same kind of sensors towards the robot to enable same flexibility. And by making dedicated application plugins, we can address the robot to do a specific task. Last but not least, we also give the operator a teach method, so he is able to teach the robot to do the task according to his needs. So these teach methods, one side we have a mimic system, mimic technology. This is for us to transfer human skills towards a robot. And we use that to, for example, what you see here in the video, to polish complex objects. Where the manual worker just does manual the job, it is recorded and will be replayed by the robot, what you see here on the right side. The other side, we have AutoPath, and that is used when we are planning a path on a 3D image, and it's used for more curved surfaces. So it's an automatic path planning software that is used also with the ITP project in this case. We call this solution CraftMate. So how does CraftMate work? There are 3 simple steps. The first step is you take a 3D image of the object that you would like to process. Then the operator gets a 2D image in front of him where he can select one area or multiple areas, but also a path that he would like to do. He then can configure the force that he would like to apply on the object, or the path width, the tool angle, etc. He then saves the program, and then he can let the robot run the program over and over again if you have the product into a fixture. So what value does this bring? So it increases dramatically the safety on site, your productivity will increase, the quality output will improve, your waste will reduce, and your reconfiguration time will get from days to only minutes. And of course, it enhances your workforce because they will be able to operate it themselves. And we can do this all without using one line of code. So how do we collaborate? We, as Nordbo Robotics, are delivering software and accessories. And together with system integrators or machine builders, we build flexible solutions for the end user. So if you have any challenges yourself, please contact me on the details here given on this slide. Or if you are close by to Odense in Denmark, you're always welcome to visit Nordbo Robotics. I will give my word to Mikkel from ITP Aero, and he will explain some more about the project we did with ITP Aero in Spain.
Okay, thank you both for your presentation. Well, our 4.0 goal remains on efficient and sustainable propulsion, and all starts in our smart factory strategy and its main pillars. 2 of them have been explored in Bain 4.0 program, 3D printing and robotics. But 3D printing is not just to print, it is much more. The collaboration with Nordbo Robotics has offered ITP Aero to accelerate the development of technologies like post-processing and finishing using robotics. There is a promising beginning in additive manufacturing in ITP era, but there is still a future in which smart robotics and autonomous algorithms will support a sustainable, safe, and efficient human work. This is a promising result and another step forward to a sustainable flight. Thank you very much.